all, I am going to show you guys how to use the elimination method to solve a system of linear equations. So when you have two systems and they're already in standard form, that means the x, then the y, then the constant on the other side of the equal sign, I would select to use process of elimination. Elimination eliminates one of the variables. Now, as I'm looking at both of these equations, I see that it's not easy to just eliminate one of the variables. I'm going to have to manipulate one of the equations in order to eliminate them. So I'm looking at the coefficients. The coefficients of x is either 5 or negative 3. Right? I'd have to manipulate both of the equations if I wanted an integer in order to eliminate the x. So I'm going to look over at the y's. Technically, it's a 2 and a negative 1, right? So I think that I'm going to use the y's because it's really easy. If I multiply the entire second equation by 2, that means I'm going to distribute a 2 to the negative 3x, the negative 1y, and the negative 14. So if I do that, I should be able to use the elimination method pretty simply, right? So I'm going to write that 2 times negative 3x is negative 6x. 2 times negative 1y is negative 2y. And 2 times negative 14 is a negative 28. Now I'm going to rewrite the original first equation technically at the top. 5x plus 2y equals 20. All right, the way elimination works is we're going to add both of the equations together, and that will actually eliminate the y's, because if you see the coefficient of the top y is negative 2 and the coefficient of the bottom y is positive 2, when you add negative 2 and positive 2, you get 0 y's, and anything times 0 is 0. Now for the x's, I get negative 6x plus 5x, and that gives me a negative 1x, right? And negative 28 plus 20 gives me a negative 8. So what this tells me is negative 1x is equal to negative 8. But when we solve, we don't want to know negative x. We're looking for a positive x. That means I'm going to divide everything by a negative 1. So I can get x by itself. And x is equivalent to 8. Now that I have that, I can actually use x equals 8 in any of the two original. So I'm going to rewrite one of the original. I'll rewrite the top one. So 5x plus 2y equals 20. And so now I can use this x equal to 8 and substitute it in for the x in the equation and solve for y. That's exactly what I'm going to do. Instead of an x, I'll put an 8. Okay, and everything else stays the same. So 5 times 8 is 40. 40 plus 2y is equal to 20. I'm going to subtract 40 from both sides because I want to isolate the y. I want to get it by itself. Right? And I am left with 2y is equal to negative 20. Finally, to get that 2 coefficient away, I'm going to divide both sides by 2, and I've gotten y by itself now is equal to negative 10. So our solution to this equation or system of equations is 8 comma negative 10. And since I used the first one, I'll use the second one to check it. So negative 3 times our x value, which is 8, is negative 24, right? Negative 1 times our y value of negative 10 is a positive 20. Oops, sorry, positive 10. Positive 10. So when I take negative 24 and I add 10 to that, I get negative 14. So yep, it's equivalent. It worked out. So my solution is in fact negative 8 comma 10.